What is down regulation of receptors? And when we refer to this up and down regulation in the context of receptors, think of it sort of like your body's thermostat, not necessarily for temperature in this example, but just some sort of meter that determines when things are needed more or needed less. And it's very dynamic. So it's not like at this one moment you're constantly going to be taking less or more of something. It's as needed. So for example, in upregulation, just to review the differences, in upregulation, the body is trying to make use of more sensors as needed. So let's say, for example, you're trying to hear someone and they're whispering and you need to hear better. So your hearing receptors would increase in that moment so that you could understand more of what's going on, as opposed to down regulation, which would be the opposite. If you have too much of something, the body is getting overwhelmed, we need to get rid of it. So let's say you have many receptors that are available, and let's say that all of these cell receptors are used to secrete insulin. Then you might have way too much insulin, the blood sugar levels could go way too low, so the body needs to compensate by down regulating, and let's get rid of some of these receptors so that we don't have so many. We don't need all these receptors right now to balance it out, because the theme of this section is all about homeostasis and balance, and down and up regulation is useful to help balance out the body so we don't have too much of one thing. So this question is asking specifically about the down regulation. So that would be this example we talked about over here. So looking at the choices to see which one would match this example about down regulation, option A is saying a decreased number of receptors or their affinity to a ligand. So would that be an example of the down regulation? And it sounds like it would be, because we're decreasing the number of receptors and its affinity, because we don't want to have these many receptors right now. So that's what we see over here. We got rid of some receptors when we had too many. So option A is looking like a good example of explaining what down regulation is by definition. So we could go with option A. Now just to review options B, C, and D, take a look at option B, how it says inhibition, and then option D says activation. So the turning on and the turning off of receptors, although that also could be used for many different reasons, it could be done for also compensation reasons, it could be done by medications, by an external source to be effective based on how it turns on or off certain receptors as needed. However, when we're looking at this down and up regulation concept, this has to do with the elimination of certain receptor sites or adding on certain receptor sites. So when you see inhibition or activation, we could eliminate those. That would not be down or up regulation. And then looking at option C, increased number of receptors to their affinity to a ligand. This is the opposite of what we were looking for option A. As you see, decreased number of receptors was down regulation. In option C, when it has increased number of receptors, that would be the opposite. That would be that up regulation. So option A would be the correct choice here.